Distinguished ladies and gentlemen, let us find the eigenvalues of the matrix that you have been given. That is 3, 0, 0, negative 1, 2, 0, 2, 0, negative 3. So we want to find the eigenvalues of this matrix. So the first step that we will take in finding the eigenvalues of this matrix is we will have A minus lambda I. So this is our A. A is the given matrix and lambda is the eigenvalue. Then I is the identity matrix that has the same order as the matrix given. For example, the matrix that we have been given here is a 3 by 3 matrix. It has 3 rows and 3 columns. Therefore, this is a 3 by 3 matrix, and therefore, the identity matrix here also must be of the same order as the matrix given. So we will have our A as 3, negative 1, 2. Then we have 0, 2, 0. We have 0, 0, negative 3. Then minus lambda times the identity here will be 1, 0, 0. Then 0, 1, 0, 0, 0, 1. Then, so we will have, this is 3, negative 1, 2, 0, 2, 0, 0, 0, negative 3. Then we have minus lambda times 1 is lambda. Lambda times 0 is 0. Lambda times 0 is 0. Then lambda times 0 is 0. Lambda times 1 is lambda. Lambda times 0 is 0. Lambda times 0 is 0. Lambda times 0 is 0. Lambda times 1 is lambda. So then we can now subtract. We can now say 3 minus lambda. We will have 3 minus lambda. Then we have 0 minus 0. We have 0. 0 minus 0. We have 0. Then negative 1 minus 0 will be negative 1. 2 minus lambda will be 2 minus lambda. Then we have 0 minus 0. We have 0 here. 2 minus 0 is 2. 0 minus 0 is 0. Then we have negative 3 minus lambda will be negative 3 minus lambda. So that is what we will get when we subtract this one with this. So now we will have to find the determinant of this matrix so that we find the value of lambda. So in finding the determinant of this 3 by 3 matrix that we have obtained from saying this matrix minus this one. Now, so the determinant of this will be, we take the positive sign of this, that is 3 minus lambda. Then, if we take the positive sign of this, then we multiply with, we close this, the first thing we close this row, then we close this column. We remain with this 2 by 2 matrix. Then we have to find the determinant of this 2 by 2 matrix. So we will take the positive sign of, not the positive sign, but the positive of 3 minus lambda. So I'm saying that you take the positive sign of this, then you multiply with the determinant of this 2 by 2 matrix that have remained after closing this row and this column. So we will have the product of the elements of the main diagonal, that is 2 minus lambda. Then we have negative 3 minus lambda, that is negative 3 minus lambda. Then we have to close here this way because we are multiplying the positive of this with the whole of this, the determinant of this, because the reason why I have closed here is that we have the determinant of this 2 by 2 matrix is that the product of the elements of the main diagonal minus the product of the elements of the secondary diagonal. But the product of the elements of the secondary diagonal is 0. Therefore, if I minus 0, it is just the same when I write the product of the elements of the main diagonal only, because 0, there's no need of writing 0. Now, then, next we will have the negative sign of this, that is the negative sign of 0 is just 0. Then I close this column and I close this row. Then I remain with this negative 1 and this 0, then 2, negative 3 minus lambda. So if I have this, the negative sign of 0, which is just 0, times we have the elements of the main diagonal, the product of the elements of the main diagonal minus the product of the elements of the secondary diagonal. If I have 0 here, then it will, and any number with any number multiplied by 0 is just 0. That is why I will have here minus 0. Then we have now this positive. You take, that is, here was positive, then negative here, then we have positive here. So I take the positive of 0. I multiply with the determinant of this 2 by 2 matrix that have remained after closing this column and this row. So the determinant of this is just, if I have 0 here, 0 times the determinant of the matrix will just be 0. That is why I will write here plus 0, then I equate with 0. So that is how we can find the determinant of any matrix. Then we equate it with 0, and then we proceed to find the value for lambda. That is how you can find the eigenvalues of a matrix. That you find the determinant of the resultant matrix, then you equate it with 0. Now, this one is 3 minus lambda. Then we have 2 minus lambda. Then we have negative 3 minus lambda is equals to 0, because minus 0 plus 0 is just 0. So there is no need of writing this. Now, since we have this on the bracket, this on the bracket, and this on the bracket, that means that 3 minus lambda is 0, or 2 minus lambda is 0, or negative 3 minus lambda is 0. Therefore, the value for lambda here, because if I take lambda here to the other side, then it will be positive, then our lambda will be 3, and here our lambda will be 2, and here our lambda will be negative 3. So lambda 1 is 3, lambda 2 is 2, lambda 3 is negative 3. So that is how you can find the eigenvalues of a matrix of any order. This is a 3 by 3 matrix, but as you can see, it is very simple, since we have 0 here, we have 0 here, we have 0 here. That is why it is not so long. But finding the eigenvalues of a matrix of any order, you will just have to find, you will have to subtract lambda I from the given matrix. Then after obtaining the resultant matrix, then you proceed to find the determinant of that matrix. You equate it with 0. Then after equating it with 0, then you proceed to find the eigenvalues by solving for the value of lambda, because the values of lambda will be the eigenvalues of the matrix. So how I wish that you could subscribe to my YouTube channel, then you could share, then you could comment. Thank you.